Today we're going to work on multiplying fractions and mixed numbers, but before we do, I just want to do a quick review of a few skills that you need to know before you can successfully multiply fractions and mixed numbers. First, a little note about simplifying fractions. Remember, if the numerator and denominator have a common factor, you can simplify that fraction. So for example, 7/9 and 13/16 are both in lowest terms. Because 7 and 9 have no common factors, 13 and 16 have no common factors. But 10/15 is not in lowest terms because 10 and 15 share a common factor of 5. So that can be simplified to 2/3. 8/12 can be simplified because 8 and 12 share a common factor of 4. And that's going to give us 2/3. And typically when we are working with fractions, we typically want to simplify our answers to lowest terms. So that is one skill that we need when we're working with multiplying fractions and mixed numbers. Now, another thing we need to remember is what are proper fractions versus improper fractions. Proper fractions have a value that's less than 1 whole. Improper fractions have a value that is greater than or equal to 1 whole. And I gave a couple of examples here. And the dead giveaway is look at the numerator compared to the denominator. 5 is less than 7. 12 is less than 16. If the numerator is less than the denominator, then it's going to be a proper fraction. However, if we look at the numerator and the numerator is either equal to or greater than the denominator, then your fraction is an improper fraction. And that's important so that we recognize that proper fractions stay proper fractions, but improper fractions can be changed into mixed numbers. So just to review that a little bit, if we want to change a mixed number to an improper fraction, remember how we do that. We multiply the denominator by the whole number and then add the numerator, making our new numerator. And then we keep the denominator. When we did this earlier this year, it kind of looked like this. We did it like this. We said, okay, so we would start here at the denominator 4, and we would work our way around. We would do 4 times 3 plus 1. Because 3 wholes that each have 4 pieces would be 12 pieces plus 1 more equals 13. So our new numerator is 13, and the denominator, of course, stays the same. So the denominator is going to be 4. So 3 1/4 equals 13/4. For 5 2/3, again, we're going to multiply. If there's 3 pieces in each whole and there's 5 wholes, then 5 times 3 is 15 plus the other 2 pieces. So 3 times 5 plus 2 equals 17, and our denominator is going to be 3. So 5 2/3 equals 17/3. Now, if we want to go the other way, changing an improper fraction to a mixed number, then we're going to use division. We're going to divide the numerator by the denominator, because remember what a fraction is. A fraction really is a way of writing division. And then the remainder is going to be the numerator of our fraction. The denominator is going to stay the same. And we simplify the fraction if we can. So for 15/2, that really means to do 15 divided by 2. And if we solve 15 divided by 2, we're going to get 7. 2 goes into 15 7 whole times with 1 left over. So 7 remainder 1. Think about just bringing that denominator right over here and putting it under the remainder. And there's our mixed number. So 15/2 equals 7 1/2. 2 goes into 15 7 whole times with 1 left over. 7 1/2. For 18/4, we can think about 18 divided by 4. 4 goes into 18 4 whole times with 2 left over. So we're going to get 4 and 2. The denominator stays the same, 4 2/4. 4 2/4 can be simplified to 4 1/2 because I can divide both numerator and denominator by 2. All right, now this brings us to really what our true lesson is today, which is on multiplying fractions and mixed numbers. So multiplying fractions and mixed numbers, I want to first point out to you before we even, as you read over this, that really the steps are change everything to fractions, multiply straight across, simplify. That's it. Again, change everything to fractions, multiply across, simplify. That's how you do it. This step right here, I'm going to show you this step today, cross simplifying. This is an optional step. You do not have to do it. However, it can make your life easier when it comes to the last step, which is reducing or simplifying. So I'm going to solve a couple problems first, and I'm going to do it without using the cross simplification, and then I'll do it with so that you can see where that can be to your advantage. So our first example, 2/3 times 1/6. We would just do 2 times 1 over 3 times 6. It's truly that simple. 2 times 1 is 2, and 3 times 6 is 18. And then we can simplify that because 2 and 18 can both be divided by 2, giving us 1/9 as our answer. Now 1 1/3 times 5/6. We have to first change the 1 1/3 to an improper fraction. So 3 times 1 is 3 plus 1 is 4. So we get 4/3 times 5/6. When we multiply across, 4 times 5 is 20, and 3 times 6 is 18. I can simplify 20/18 because I can divide 20 and 18 both by 2, giving me 10/9. Now, this is an improper fraction. In some situations, we may want to leave our answer an improper fraction, and in some situations, we may want to change it to a mixed number. So I would really just want you to know that this is a correct answer. However, it can also be changed to 1 1/9, which would be the mixed number form. And sometimes you're going to be asked for a specific form. Sometimes, depending on what the situation is, you're going to want to do it a certain way because it's going to make your next step of whatever problem you're solving easier. And we'll talk about that more as we work with fractions. All right, now let's talk about that step of cross-simplifying. Cross-simplifying is not required because notice I did both of these problems and solved them, no problem, have the correct answer. But sometimes you can cross-simplify and it may make your problem easier. Let me give you an example. You can cross-simplify on both of these problems, so let me show you how you could do that. So cross-simplifying means to look at your numerators and look at your denominators and see if you have any one numerator and one denominator that have a common factor. So for example, I could look at the 2 and the 3. They don't have any common factor, so I can't do anything with those. The 2 and the 6, however, do have a common factor, meaning a number that goes into both of them. They can both be divided by 2. So I'm going to divide them both by 2, and I'm going to write this right here beside it so I can see I'm dividing by 2 on the top and I'm dividing by 2 on the bottom. When you're cross-simplifying, it's super important that you cross-simplify a numerator with a denominator. You can't do 2 denominators or 2 numerators. It has to be 1 numerator and 1 denominator. So I divide those both by 2. I'm going to write it in, and then I'm going to go back and actually do it. So now I'm going to do 2 divided by 2, which is 1. I'm going to cross out the 2 divided by 2 and replace it with a 1. 6 divided by 2 is 3. I'm going to cross that out, replace it with a 3. So now my new problem is 1, because I've replaced the 2 with a 1, 1/3 times 1/3. I'm getting that from looking at this for my first 1/3, and this is my second 1/3. So 1/3 times 1/3. 1 times 1 is 1. 3 times 3 is 9. So notice I get the same answer that I got the first time. The difference is I don't have to simplify at the end. So what cross-simplifying allows you to do is it allows you to work with smaller numbers, basically, because I never got a number as big as 18 because I cross-simplified before I multiplied. Now, on that particular problem, maybe it's not super helpful because 2/18 was still pretty simple to simplify, but it does, we'll look at some other examples where you'll see where it could be perhaps really, really useful. All right, so looking at the second example and cross-simplifying in that one, we had 4/3 times 5/6. So what I want to do is look and see, does 4 have a common factor with 3 or 6? Does 5 have a common factor with 3 or 6? So when I look at this, 4 and 6 have a common factor. So I'm going to divide them both by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Now I'm going to rewrite my problem as 2/3 times 5/3. And then 2 times 5 is 10, 3 times 3 is 9. I still get 10/9, which still equals 1 1/9. That's just like what I had before. All right, let's look at a couple more examples. 4 times 2 1/3. So if I do 4 times 2 1/3, first I need to change everything to fraction form. So 4 would be 4 over 1. So 4 over 1 times 2 1/3 would be 3 times 2 is 6, plus 1 is 7. So it would be 7/3. Now I'm ready to see if I can cross simplify. Well, 4 doesn't have a common factor with 1 or 3. 7 doesn't have a common factor with 1 or 3. So I can't cross simplify. I'm going to just multiply across. 4 times 7 is 28. And 1 times 3 is 3. So I get 28/3. And 28/3, if I wanted to, it's improper. So 28/3 could be changed to 9 1/3. So 9 1/3 is my correct answer, or 28/3. All right, let's look at another one. So 2 2/15 times 3 1/4. So 2 2/15, 15 times 2 is 30, plus 2 is 32. So I'm going to get 32/15 times 4 times 3 is 12, plus 1 is 13. So I'm going to get 13/4. 32 and 15 don't share any common factors, but 32 and 4 do. I can divide them both by 4. 32 divided by 4 is 8. 4 divided by 4 is 1. 13 doesn't share a common factor with 15 or 1. So I'm ready to rewrite. So my new problem is 8/15 times 13/1. And it would be totally fine to come over to the side and do your 13 times 8, which is 104. And that would be 104/15. So then I would need to do 104 divided by 15. Which, when I do that, I'm going to get 6 remainder 14. So that's going to give me 6 14/15. So my answer is 104/15, or 6 4/15. All right, now those are all the examples that you have in your term notebook, but I'm going to do a couple more in case you want to write these down. It'll give you another look at that cross simplifying. So 5 5/6 times 1 2/7. If I make those both improper fractions, I am going to get 35/6 times 9/7. And if I look to cross simplify, 35 and 7 can both be divided by 7. And I know sometimes we're going to be tempted to do this in our heads instead of writing it out. Please don't do that, because you're going to be more likely to make careless mistakes. 7 divided by 7 is 1. 35 divided by 7 is 5. Now I look, and 5 and 6 don't have a common factor, but 9 and 6 do. So 9 and 6 can both be divided by 3. So notice I can cross simplify both ways here. 9 divided by 3 is 3. 6 divided by 3 is 2. So my new problem becomes 5 halves times 3/1. And that's because I have a 5/2, a 3/1. That's where those numbers are coming from. And I'm ready to now multiply. 5 times 3 is 15, and 2 times 1 is 2. And 15 halves equals 7 1/2. So my answer is 15 halves, or 7 1/2. Now notice, it would have been totally okay for me to keep that 35/6 times 9/7, and then I would have had to multiply 35 times 9 and 6 times 7. So 35 times 9 would be 315 over 42, I believe. 315 over 42. Now, if I were to want to then go ahead and simplify that, I totally could do that. But notice it's going to be a lot harder to simplify than 15 halves. So that's the advantage of cross simplifying, is because you don't get those bigger numbers like the 315 and the 42. So if you're able to cross simplify, it's certainly to your advantage. All right, the next one, 5 5/8 times 2 2/5. 5 5/8 is equal to 45/8. And remember, I get that by doing 8 times 5 is 40, plus 5 is 45. 45/8 times 5 times 2 is 10, plus 2 is 12. So times 12/5. Looking at this, I can divide 45 and 5 both by 5. So 45 divided by 5 is 9, and 5 divided by 5 is 1. I can divide 8 and 12 both by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So that's going to give me the problem 9 halves times 3 over 1, which is 27 halves, which could be 27 halves, or I can change it to be 13 and 1/2. Now, if I had not cross simplified, then my problem would have been 45/8 times 12/5. And that would have given me 540 40ths, which I could simplify and it would eventually give me 27 halves or 13 and a half. It just might take me longer to get there. So again, the advantage of a cross simplifying is just that it allows you to work with smaller numbers. It is not required for you to do, but it can be really, really helpful.